Okay, thanks for inviting me to come back. And so I've gotten to know a lot of you back when I was at Penn State University as a full faculty member and working on colony collapse disorder and looking at mites and their impacts on pathogens. 7 years ago that I transitioned over to USDA-ARS, and I get to be the research leader of the Pollinating Insect Research Unit in Logan, Utah. And we get to work with all the bee species. So we're also the home of the U.S. National Pollinating Insect Collection, i.e. the bee collection. It's a worldwide collection, one of the largest in the world, and has really important value in terms of giving us a historical perspective and a way to look at what's going on in bees. So several of my scientists work on identifying bees and figuring out who they are, Terry Griswold and Michael Brandstetter. And then I want to introduce you to Kelsey Graham and John Koch. Kelsey is one of our new scientists working on integrated pest and pollinator management, i.e. asking how can you safely apply pesticides when they're absolutely needed for pest control and protect your pollinators. She's also interested in plant pollination. John Koch is one of our scientists that works on bumblebees and asking about their methods. And then Teresa Pittsinger, she's been really instrumental in also figuring out how to get other bees into systems, working with honeybees, not replacing them, to give you maximum pollination. And then we have a whole host of great people too. So it was with this expertise, and of course I bring the honeybee side, that we were asked to do a project. And this project, we've entitled it Ensuring Healthy Pollinators for Crop Production, defining what the forage needs of the bees are through examining interaction of species and pollen use. So I am the lead on the project, so if you have complaints or concerns, come to me. But if you have good comments, want to give people credit, please reach out to the rest of the team here. So Lindsay McCabe, Kelsey Graham, John Koch, Brian Love, and Craig have been instrumental on this. This project is funded through Project APISM and Costco. And we also have to greatly thank Darren Cox of Cox Honey Limited. He's our main collaborator, and he's also given me permission to share with you some of the details on his operation today. So when I tell you about how much honey that he made, you'll know that he gave me permission. But we also had an army for this project, so I have to thank all these people, in particular those that are highlighted in blue or in red, for taking a major role on this. And so what I'm about to show you is basically, we can title it all this way: how does the presence of a honeybee apiary impact other native bees? And this is, yes, I love stepping into the hot topics, once with colony collapse disorder and now this one. This has become more and more of a pressing issue with many stakeholders on both sides of the coin who have very strong opinions and wanting to do things. So Danielle Downey, who's here, and I have to thank her for a lot, she actually came forward and asked me on the behalf of beekeepers and others about doing this project. And she had to ask twice because I knew it was going to be a major controversy. So I did consult with my national program leader, now that I'm in the federal government and have lots of people above me, Kevin Hackett, and he agreed that we could move forward with it. But as I told Danielle and told other people, the only way that we were going to do this is if we could do it in a very rigorous way, getting the best quality data, and we were going to go in with an unbiased perspective. And no preconceived notion either way. In fact, I even banned the word competition from being used by anybody who worked on this project. That we were looking at the interactions of bees and figuring out how they all work together. And then we will report our data and findings to inform others. And this is another caveat that I learned with Agriculture Research Service. We do the research, we get the data, we make scientifically sound conclusions, and then we share information to inform others that do policy, but we do not do policy. So what I'm about to show you is hot off the press. I presented it at American Honey Producers for the first time last month, but we're moving forward right now to get this out into press and to share it with others. So let me give you the background here, why this is important. So you guys, when you're out and about and looking out in your fields and your flower gardens, or you feel out where you have your bees, you know that you see incredible diversity. So bees, there's about 20,000 species worldwide. Here in North America, there's over 4,000 species. And as you know, these are keystones for both agriculture and for our natural ecosystems. They're absolutely essential. And over 80% of all the flowering plants out there require pollination. So everything that we see around us is highly dependent upon it. And as you know, if we lost honeybees and the other bees, we'd be left eating grains, potatoes, and crops that you could go out with a paintbrush and do the pollination yourself, which I don't think many in the US would be wanting to do it. We do know from our work in our lab that we can get non-honeybees, other species, to go out and work in crop pollination. And our group has been very successful, showing that if we bring in blue orchard bees, for example, with honeybees, they synergize with honeybees. They work together and give you even greater fruit nut yield. And from our work, we don't see any negative impacts coming from honeybees back to these other bees. So they're working together. We also know that these other bees out there are essential for the natural ecosystems. And just in case you didn't know, we have incredible diversity in the US. So this is showing where all those bees are. The darker the purple, the blue here, the more species that you have. So Southwest US, which is one of the toughest places to be out there, we actually see great diversity out there. And who are these other bees? We range from solitary bees. You have to think of these being like single moms. Each female bee is responsible for creating her own nest. She goes out and she forages, brings in the pollen, and then nectar, creates what we call a pollen provision, lays an egg on it, seals that off, starts a brand new cell, and keeps adding on and on. And there's incredible diversity. This is the largest group of bees out there, both ground nesting bees and cavity nesting bees. And they vary in terms of when they show up in the environment. Some are very early, some show up later. So mom, she never gets to interact with the larva at all. It's always on the larva to grow up and develop on itself. And they overwinter, go through diapause or hibernation. And it's really hard to find these nests. So even my scientists who are like experts can't easily go out in the field and look for them. Same thing for bumblebees. A bumblebee, the colony is only 1 year in lifespan. So the queen bees who grew up the previous year, they hibernate in the ground. They come out in the spring, and that queen is responsible for creating her own colony. Goes out and gathers that pollen. She actually warms the developing brood in there, maintains temperature. And then once a lot of the workers grow up, she switches completely over to just being reproductive, like a honeybee queen. And then you get the males and the future queens being produced in the winter or in the fall, and they mate, and then those queens, the future queens, go through diapause. Honeybees, which you guys know extremely well, you have that one essential female in there, that queen bee who's mother to all. And she's responsible for laying. You have the other worker bees in there, nurse bees, taking care of that young and rearing them up. One of the things that a lot of people on this native bee side don't appreciate is when we say there's a healthy colony of 40,000 individuals, that you have a very small proportion of that colony that are out and about foraging at any time. The rest of the bees are inside taking care of that brood and keeping that colony warm in there. But you have this resilience in numbers. So, back to the question here. This is something that would make most beekeepers drool to find a place like this where you could put your colonies. This would be great, but this is something that seems to have been long gone for a lot of reasons. And we know now that we need to increase bee pasture for others. So somehow this lost the color on it, but You can see our 4 Ps here, and I have to thank Jeff Pettis when he shows up here for generating that 4 Ps. Pesticides, pathogens, parasites, and poor nutrition, you've probably heard, are major stressors on bees, and they interact together. We have to put on around this climate and climate change as being the other factor that's been affecting this. Back at CCCD, we talked about poor nutrition. It was one of those factors then, but I want to argue now that it's become a major factor, a predominant factor, because one of the things that we've seen is a decrease in floral resources because of our actions as human beings. So we've changed the land use. We've increased the amount of herbicides that are being used out there, both cleaning up the environment, making things neater, and removing the weeds and the flowering plants that most bees had before. And then we also have the fact of climate change, drought in the west, and then excessive rain and drought out here in the east. And so what we're seeing is a decrease in honey production, an increase in annual loss of your honeybee colonies, but we also know that we have concerns about many other than native bees. We now have several bee species added to the endangered species list, and concerned about their populations overall, because as I said, we can't go out and easily look for these where the nests are, the colonies. So we do have this need to create more bee pasture. So back to the research question, how does the presence of a honeybee apiary impact native bees? So to set up this project, we realized that all of these different bee species require pollen and nectar sources for reproduction and colony growth. And that's the critical point here. When you're going to talk about if there is competition, negative impact, you want to ask about reproduction. And this has been an issue that's come out in a lot of papers, and a lot of those papers come from Europe, where they're talking about competition between honeybee apiaries and native bees. So to me, though, this is sort of a misnomer, because if you're talking Europe, honeybees are a native bee to Europe. They're there, and what we're talking about instead, I think, is exceeding the carrying capacity in what you have there. So we have to think of this like a breakfast down at the buffet. If they had stopped serving food and you had everybody in the room here show up, we would have exceeded carrying capacity. They would have run out of food. And that's what I think we're at with some of our bees, is defining what carrying capacity is. How can you bring in the bees to deal with this limited resource of floral resources? Ideally, we'll overcome that by planting more flowers and getting it out there. It's not only bees that want these flowers, there are other things that want to eat those too, so herbivores, like cows and sheep, and I'll bring those in there. We also think about some of these native bees. Some of them are specialists. They have a one-to-one relationship with their plant species. They depend upon each other. So asking how has that impacted, we can also ask, are there any bullies out there, bee species? Is it honeybees just pushing all the other bees off the flowers? Is that what's happening? And then lastly, pathogen transfer. So on that issue, we're still analyzing that data, but we know that some of these diseases, viruses like I worked on previously, are shared amongst all the pollinators. It's just like COVID. COVID is shared amongst lots of people and probably other animals, but having the virus in your body does not mean you have COVID. It's when you add in other stressors that trigger that into being an active disease. So just finding it, the disease there, the pathogen, the organism, does not mean that it has an impact. But we can ask, is there transfer and spillover and sharing? And that's where our collection of the historical use of bees, we might be able to go back and ask, was that disease there previously? So how did we do this? Well, we set up sentinel bees. So our unit is unique in the fact that we could create sentinel bumblebee colonies and sentinel solitary bees and put them out there with these honeybee apiaries at different distances and ask, what's the impact on reproduction? How do they interact with each other? So we have match sites on Forest Service land and private land to mix it out in there. One with a honeybee apiary, and about 7 kilometers, over 5 miles away, we would have a non-honeybee apiary with our bumblebees at both sites, and solitary bees there and in between that we can monitor. So let me introduce you to our bees that we used, because they're pretty cool, I think. The first up is this solitary bee, Osmia bruneri, and we don't have a nice catchy name for it. We just call them bruneri. But there's this fantastic, beautiful little bee, metallic-y green-blue. And the way that it likes to make its nest is it masticates leaves and creates partitions in the cavity. So you can see the little block of wood there down at the bottom. That's where we have our holes drilled into it. We put straws in there and put it out. We seeded these blocks with some of the solitary bees that we'd grown up and released, about 15 males or 20 males and 20 females at each site. So both at the honeybee apiary, the non-honeybee apiary, and then 5 sites in between at different distances. So we could measure it going from honeybee apiary and further out. Our bumblebee here is Bombus huntii, the hunt bumblebee. And it's one of the cutest little bumblebees. This is native to Utah. And here you can see one of our colonies that we've started up. We go out and collect the brand new giants in the spring and get them up and going. And we can get them on pollen, and she grows up and produces them. You can see that down in the bottom right-hand corner, you can see a little pot there with a glistening liquid in it. That's their version of a honey pot. It's not honey per se, so definitely would be selling it here on the market, but it is there and present. And they also warm their colonies. So here over on the far left, you can see the infrared image showing the yellow color. That's them actually producing heat and warming the bees. And these bees colonies can get quite large, as you can see in the middle here. So what we did is we can get them up and going, and then we created a little box for them to go in, put the colony in. We also figured out how to go peek in there without disturbing it. So we used this instrument here that you would peer down into plumbing in that. We could actually go in and take video and pictures and see what was going on in there and monitor it. So just showing it being put together here. We have temperature sensors inside. We also developed monitors to look at foraging of both bumblebees and the honeybee colonies. And we were able to get this to work up in the mountains where we didn't have cell phone service or that, so we can record the data and look at it. Okay, so back to competition, the bad word here. So I also realized you can't say whether or not you have competition unless you actually define what it looks like. So what we did is we had cages, very large cages, that we could put the different bees in, species together or by themselves, with limited floral resources, so we can generate that, not having enough food, and ask what happens when that occurs. And so we can also ask about the different flowers that we put in there, different plant species, how they sustain things. The first year in 2020, we did this with a flower called Phacelia, and we knew that this worked really well for the solitary bees, that they could do really well. So here's Osmia bruneri. You can see in cages with all the other bees, and it did great. The bees that didn't do great in this case were honeybees and bumblebees. They just petered out. Those colonies declined over time and went downhill. So what we have now is a mystery. How does Osmia do so well with a single plant source, whereas honeybees and bumblebees need this other? And that's something that our lab will hopefully deal with here. So we changed it up a bit. We added in 10 species of plants in here. And we also planted this in 3 identical sections and expanded the number of cages that we're looking at. The plants that we used are here 2 of them, the native plants, Collinsia and 5-spot, didn't do so well. So we excluded it, but they include some of your favorite flavors of honey plants here. The sweet clover and red clover in there too. So this is just showing what the cages look like inside. The white box in the back is one of these Ecobee boxes. It's like a miniature length colony with little frames. That's where we put our full-size packages in these. We normalized the colonies so they had the exact same number of adults. We let them get up and going for 2 weeks before we put them in there. We have the bumblebees in our larger container, and then the solitary bees, you can see the block here in the little blue, we call them Fiesta mailbox plastic shelters here that we can peek in and look at. So people were concerned if we put these bees in there, is the honeybees just going to keep battering themselves trying to get out? And so no, we did not see this. We see that when we look at it, yes, there are bees trying to come out to the walls of the cage, but we don't see honeybees being over excessive there. We also asked, was there any bullies here? Are honeybees just excluding all the other bees off? We know that there are some bullies out there. There's an invasive wool carder bee shown up here in the upper left. This is a bee that got introduced, and you probably have seen it out there. It actually, the males patrol flower patches, and they will actively attack other bees and bite and keep them from getting in there to foraging. So when we did this in the cage study here, we saw that bees, when they're alone by themselves, the different species, we do see them bumping with each other, but we didn't see extra bumping when all 3 species are together. We didn't see any increased interactions. One thing that our people did was they were following individual bees is they saw mid-air collisions, especially when you had all 3 species together. So we sort of needed a flight control person out there to tell them how to get around. But they survived on that. We did see the male Osmia bees, because we put males in there to mate with females, that they were disrupting the females. My crew don't like me to say, but what do you expect? Anyway. We did see that there were top flower choices by all the bees. Phacelia, the one that I said the Osmia did really well on, all the bees still liked it. So honeybees and bumblebees did recognize it, but also sweet clover was a top one. The purple bar here for the bumblebees, they're the middle set on the graphs, is sunflower, and the bumblebees did like sunflowers much more than the others. In terms of asking how did it change behavior, we didn't see, so this is graph, the different color bars are the different flower species, and when they're alone, it's on the right-hand side of the bar there, the blue bar, and 3 together. It's only Osmia that we see this change over, that on one of the plant species, I think it's Gaillardia, you see them visiting much more often when they're all 3 together. And on the red clover, the number of visits that they made decreased when all 3 were together. But that was the only change that we saw in behavior. In terms of reproduction, we did see that when we had all 3 together, we did see decreased reproduction. The number of nest cells that mom made went down when all 3 were together. We also saw this impacting the bumblebee colonies here. Looking at both at the amount of organic material the bumblebees make a wax as well. We see a decrease there in the number of open cells going down. But we also saw that in honeybees, that the colony size and that went down when all 3 bees were together. So what we saw was, yes, indeed, that you can exceed carrying capacity, but it affects reproduction amongst all 3 of the species uniformly. It's not just an impact on Osmia and bumblebees, but honeybees are being impacted as well. We did see some shift in behavior when there were all 3s together, But we also learned that Osmia seemed to be doing a lot better on a single flower source than all the others. And lastly, there were no bullies. Back when I was at Penn State, we did do a study inside a greenhouse where we put bumblebees and honeybees together, giving one a virus and the other a virus. When one of the colonies, either honeybee or bumblebee, were affected by the virus, we saw that the other bees would actually come in and invade. But it was a uniform invasion. So it can happen if the competition's there and your colony is weakened, you'll see other things coming in, which I'm going to about tell you about here. So we defined what competition looks like. So let's go to the field and ask what we see there. So we not only did our sentinel bees, but we looked at who were the endemic bees, the bees that lived in that environment. And so the way that you look at those is you can do two things. We can put out these little bowl traps of soapy water in these colored bowls, and bees are attracted to them, white, yellow, and blue. And we can also go out with a net. And so we set up transects at each of the sites, the apiary site, the non-honeybee apiary site, and then the 5 sites in between set up transects that we monitored every 2 weeks and collected bees in there for a certain amount of time. We did the collection of these. We've pinned these bees. We're identifying them. This is the first ever survey of native bees in this particular mountain, so it's going to have value in that regard. And there's over 10,000 bees that we've collected here. So we also quantified floral resources, asking how much is out there. And we did this 2 ways. We did it walking a transect and quantifying the flowers, so recording exactly what flower species it was, how much we saw in a bloom there. Did this every 2 weeks, but we also were fortunate to have Jesse Tabor work with us. He's a recipient of Christy Hines Memorial Award. And Jesse's shown here on the left. He got his master's with us. He actually flew this drone here, was able to capture digital images and quantitate down to about 1 centimeter square inch. So flying 50 acres in about 30 minutes. And we were able to classify floral resources. So we're hoping to carry this forward here. We also looked at what weather was doing. Drought did play a factor. 2021 was a major impact of the year. We see below precipitation and snow melt, also elevated temperatures, and this showed up in the plants out there. So this is seen from up in the woods, and if you look at these plants here, you can see they're sort of curling and graying. This is a drought. These plants are actually drying up. This is mid-July. Normally the beekeeper, Darren Cox, would keep his bees out there until late August. And we didn't do all this tromping around out there. We carefully walked through the plants. The tromping here, all our lands had cows and sheep on them. The cows and sheep are also actively looking for things to eat out there. So in 2022, this is showing another picture here. We got a lot more rain and milder temperatures, so we see a lot more bloom going on until early August here. And the cows are still out there. Okay, so Forest Service, back in the early 2000s, they had this saying or a motto, a land of many uses. And I have to tell you, this is very true. Their current mission is at the top here, but the many uses that we see there is recreation. This went way up with COVID. So everybody and their friends and family were trying to get out and about. So we're north of Salt Lake City, a big city. We see a lot of people coming out camping wherever they can find a place to pull over off of a road and put their camp and stuff. But we also see a lot of ATVs coming up, so actually like groups and stuff. So this picture here, I was out there with a graduate student, and it's like 10 ATVs went by, and you see all this dust clouds coming up. That's also going out over the flowers and stuff. We also see grazing. There's active grazing permits on the Forest Service land and also our private ranches. And then Darren Cox had his historical permits, he still has. And then there's hiking and horseback riding, and actually very little forestry going on, but a lot of use here. That grazing does make an impact. We caught an introduction of sheep. They brought 7 truckloads of sheep into one of our sites, the non-honeybee apiary site, and just dumped them right there. This shows you the flowers on the left before the sheep got there, the flowers the day after the sheep went through, and I was totally surprised. And in my background, my dad came from a family that ran sheep up there, so I'm not anti-sheep, but those sheep just mowed the flowers off. They didn't touch the grass or anything else. They just mowed every flower. There's 1 flower left in that picture there. And so grazing is part of the issue too. Carrying capacity is not only for honeybees, but all these other herbivores. And our monitors here, that purple bar there is the day that the sheep are introduced. And what you're looking at here is bees going in and out of our bumblebee colonies. And you can see over on the left, that's early in the season. Over on the right, it's later. You can see the intensity of the dots there increases. That's colony building up. But the sheep did make an impact. We see other things showing up on our monitors here too that we think might be other things coming and disturbing it. One cool fact that we did learn from this is that bumblebees are active even in the middle of the night. We're seeing them going in and out of our colonies dead in the middle of the night, midnight, 1 p.m. Maybe they're out at the bars, I don't know. But there's something there that we're going to follow up on. Okay, so let's get to the flowers themselves and what we saw. So looking at floral abundance, how many flowers there? The number of flowers did not differ between our 3 parent sites. And they also did not differ between honeybee apiary versus non-apiary site, but year did make a big impact. That 2020 one I showed you with that drought year was a great impact on the number of flowers. It's greatly, significantly different. We could also ask about diversity of flowers. Do they have the same diversity? And they don't. Some of our sites, even though we tried to match them as much as possible, were not as good as the others. That Twin Creeks, the one over on the right-hand side on the graph on the right, was much fewer types of flowers. And that site had some issues. I'll come to it and show you it here in a little bit. So if we look at what honeybees are visiting versus other bees, so the apiary site versus non-honeybee apiary site, you can see that they do differ. The apiary site at Twin Creeks had much fewer honeybees visiting the flowers, and there was less diversity. The most common species that we see up in these wild areas were horse mint, which seems to be a great bee plant, potentialia, rabbit brush. You guys can ask me about rabbit brush later. It's one of my pet projects now to get it out there, and a wild geranium. So this kind of shows you the split here between honeybees and non-honeybees. The thistles here, this is an invasive thistle that was introduced on one of the private ranches here in Blacksmith Fork. The other bees really liked it. Honeybees were not the ones pollinating it and helping it to set seed. We also see that we're getting honeybees collected across the season, as well as the other bees. And one of the things that we discovered is that we can get honeybees to show up in our pan traps. Previously, people didn't think honeybees could be monitored that way. So we are seeing the honeybees, that's the stippled bars here. The arrow is bumblebees. We saw 1 bumblebee out on our flowers, even though we knew the colonies were there. There are a lot of other species of bumblebees up there. And then the osmia is this star bar here. There's a lot of other osmia species too. We saw that we could see that you can more apt to get a non-honeybee the further away from the apiary that you are, except for Franklin Basin here. But I don't think it's highly significant difference. In terms of apiaries, we did mite counts on these. The mites, Darren Cox had a great success in keeping them low. There's only 1 colony in 2020 that had significant number of mites. At the end of the season, had 12 mites for 200 bees. And so we did look at mites across the season for all these honeybee colonies that were there, and they were in control. Whoops. Okay. All the sites I told you about did have cows or sheep. 2022, we did see a few other stressors come in. A bear came in. It sounds like I was back in Pennsylvania where bears were really common. And it destroyed one colony. The cows did want to brush up and scratch themselves on the boxes, so we actually straightened some of the colonies after that happened. But we did look at what the colonies did. So this is showing you one of the sites here. Darren used either newly purchased, established queens, and the workers came out of colonies that came from almonds. And 2020, 3 of the 48 became queenless and were dead by the end of the season. But he did make great honey there. 2021, we also see the queen status, that some had to be requeened. There's one drone layer. And this was the not great year, so there are fewer of the heavy boxes on the honey supers. Those are the orange bars over on the right there. A lot more were the green bars with low honey production. And this shows up in what Darren shared here on his honey that he produced for all these apiaries colonies. So he had other apiaries up in there, so ours were 144 of the 624, but you can see 2021 was definitely a bad year for honeybees. Okay, so what about the other bees? We had a surprise. We put our sentinel bumblebee colonies out. We have little pollen traps on the front. That's this little white box. And it has little openings in there. Within 2 weeks of putting our bumblebee colonies out, we had this bee show up. This is a cuckoo bumblebee. And you may not have ever heard of this. This bumblebee, she lacks any pollen collecting structures. She's actually a parasite. She comes in and she kills the resident queen inside the colony and then takes over the workers of the other species to get them to rear up her young. So she's a apex predator out there. So we saw these come in. Luckily, we've also figured out how to keep them out. We made that little yellow bar there you can see on the front. We made a hole in there that was such that the workers of the hunty-eye bumblebee could go in and out easily, but it kept the queen citrus bees out. And so we were able to get our colonies up and get them established. We did make lemonade out of lemons, though. So we took all these citrus, these different bees, from both the honeybee site and the non-honeybee site, and we did population genetics. We asked how were their diversity? And what we found was something really interesting, that we had a lot of different families of citrus that came from different moms, but 2 of those families were found at both the honeybee apiary site and the non-honeybee apiary site that were 7 kilometers apart, 5 kilometers. So who did the distribution? Was it mom flying around getting her bees out there, or were they dispersing out? But we also found that we had equal numbers at the honeybee apiary site and the non-honeybee apiary site, identical population genetics, saying there was no differences between those 2 sites. And why is that important? As an apex predator, it's assumed that your prey, if there's anything bothering your prey items, any disruption there, that you're going to see that carry through to the apex predator. I.e., if all your bunny rabbits disappear, you're going to see your population of your coyotes and others that are eating those rabbits go way down. We didn't see that. That means that this long-lasting apiary that was here at this Blacksmith Fort site, it's been there for 20 years at least, many times having 96 colonies. We did 48. And at other times having an additional 96 colonies up there, that those colonies did not impact the other bumblebee colonies that were out there the previous years when we did our study. So we're not seeing the honeybee impacting the prey here. Okay. We also looked at the Osmia. This is their reproduction, and you can see the distance from the apiary The further on the left is right at the apiary, further away is over on the right. And you can see the bars are not different. There's no significant difference there in the reproduction. We also see this in other years, 2022. We also have other bees wanting to make use of those cavities. We pull the straws out of those cavities when they get full, so there's unlimited supply there. There's other non-Osmia species that want to get in there. And there's also wasps, predatory wasps. But for Osmia, you can see here that bar, and it goes from the top of the graphs here. The purple is right at the apiary, further ways down at the bottom. We can look at this a different way. So the middle bar here, you can see that line is pretty straight. That line there on Osmia, we're not seeing difference in the reproduction of Osmia relative to how close or further away they are from that honeybee apiary. The one thing that is different, and this is just for 2022, is this line down at the bottom here. This is the non-Osmia bees, other species of bees that are in there. We see that there is this relationship that the closer you are to the apiary, the fewer of those bees you have versus the other. So these bees are still developing. We don't yet know what species they are. So one of our biggest questions now is to ask, is this a single species in there that we're seeing this relationship? And it's more apt to be that there are a lot of different kinds of bees, but we need to come in and ask about this. This is potentially the one negative aspect that we see of competition by the honeybees here. So on bumblebees, just to go through, we don't see an impact. We did look at queen production cells, and we see for our bumblebees actually a much higher incidence of not succeeding, failing. And this is something that nobody's looked at before. What happens to wild colonies when they're out there? And we need to come back and look at this. But we see that this failure, it's actually as apt or even more apt to occur at the non-honeybee site than the honeybee site. And this holds true for all the different sites here. And we also asked, does the starting size of that colony when we put it out there make a difference? And what we found, and the most important part over here on the right, is that we kept growing up colonies, and we put, at the end of the season, sort of like the Hail Mary, and put all the bees out there that we had. One of them, the queen, had 3 workers when she went out, and she made queen cells. There was no relationship between the number of workers when they went out, whether they had a very strong population or a small population, affecting whether they made queens or not. So, what have we learned? At this point in time, we can say, and I think this is extremely rigorous, the most data, and this first study that I've ever seen using sentinel colonies, we do not see that apiary presence impacting the reproduction of our sentinel bumblebees or solitary bees. We also are not seeing, at this point in time, and we still need to analyze who the other native bees are, the endemic bees, we're not seeing an impact there. But we do have this one little caveat we need to follow up on. So we're going to be rearing out, getting those adult bees out of these other nests from the one site, Twin Creeks, to ask who they were and how this is correlated. And we're still looking at the pathogens. COVID did impact our ability to get in the lab, so we're moving forward very greatly there to ask what are the sharing of the germs, how is that being done? And then our foraging data will have a lot more there to learn about, but I'm excited to see, because I think we're going to learn a lot about both bumblebees and honeybees' basic data there. So with that, thank you for listening, and if there's time, I'd be glad to answer questions. And I know I dumped a bunch of information on you very quickly here, so don't hesitate to come up and chat with me later. So for my days at Penn State, there's no such thing as a stupid question. And so I'm willing to chat about everything. Robin.
You were monitoring the foraging of the bees at the nest. Can you tell us how you did that?
So I have to thank Byron Love, who is one of my best technicians, really intelligent guy. He worked with Tim McCabe, and we made monitors so that would infrared and also conducted capacitor monitors that would record a bee passing through and out. And we figured out how to get that onto a time card along with temperature stamp and get it all powered using a solar panel and a battery. And it worked. Yeah. Yeah, so we're willing to share that. Question?
Naturally pruning the plants, which maybe might help it grow better later with fertilizer, and also just with natural plant growth, it's good for pruning. So do you know if that helped its plants in the future, or do you think the sheep just came through at the wrong time?
So that's a great question, and it's kind of, we know that this area had sheep previously, so I think that sheep have probably had impact in selecting what species are there over time, because if you go further up in the mountain, and it's hard to say because of moisture and just that, we see a lot more diversity if you go further up the mountain, where I don't think the sheep get it quite as much. But we came back after the sheep had gone through and eaten everything. We don't see recovery of the horse mint. That's the flower that I showed you that got mowed off. Yeah. It didn't come back and rebloom again. We saw other plants in there blooming, but we didn't see that.
Do you think it might be like a timing issue, or do you think
Say it again?
a timing issue on like when the sheep go through there that could help, or not? Maybe.
A timing issue? I'm not sure.
When I say timing, I mean
I'm
like,
not sure how the decision, when the decision's made to bring the sheep in.
Sure.
The cows show up early spring, so I know the one year that Danielle came out with Project Apis we're up there is actually the day the cows showed up. Again, with multiple semis coming out and just getting dispersed. And they stay much longer out there in the season. But this forest area is, you know, and having grown up in the West, I have this ideal, you know, what it's going to look like. But there's multiple uses going on up there. So I'm not sure that we have native natural lands out there.
Thank you.
Per se, yeah. Any other questions? Okay, so I'm not going to talk about it, but and I tried to get a plant out here to ask the question, but we do have another project that is just getting off the ground here that is being funded by Project Apis and Costco. And so one of the benefits within ARS, we have this Grand Challenge project now, a Grand Challenge Synergy project that is focused on bee nutrition. And I got to know a lot more about the other two research units in Logan. One of them is Forage and Range. And it turns out Kevin Jensen and his crew have been working with RCN and RCS, and they've been figuring out how to get pollinator plantings out there and get them established. And Kevin created his own seed mix that uses Sandpoint, this beautiful pink flower here. And I'll just show you this real quick here. So drought is a major issue. So Kevin, some of the plant mixes up in the upper left there didn't do quite as well, the NRCS pollinator plantings, and then he created this one over here on the left, that's Sandpoint, alfalfa, and small burnet. And this planting here went in 2017, 2018. This is central Utah, no irrigation, no water since then. And it's doing great. We came in there last June, so this is like 7, 8 years, maybe not quite that long, but 7, 8 years later that these plants are still there blooming. And we found a really great community of bees out there, both honeybees, probably feral bees, and these other species. So we're seeing if we can expand this and add in the pollinator plants that go into this. And this is really needed in the West because some of you in the West know it. In California, you guys know it really well. the amount of water that's available to the major reservoirs, Lake Mead and Lake Powell, they're talking about it hitting dead pool. The levels have dropped down completely. A lot of new bodies showing up around Las Vegas there, out in the reservoir. But irrigation water is extremely limited. So a lot of the lands that were previously in ag are potentially going fallow. And so getting these plantings in place might help us get the ground captured, get its soil in place, but give us pollinator, this bee pasture as well. So thanks for inviting me. And if you have questions, you want to just chat, come up and chat with me. And then I get to visit with you again tomorrow on my own research topic about pesticides a little bit. Thanks, Dan.